welcome back for part 2 of today's lesson. We are going to just jump right in, and we're going to look at what happens when you take complementary angles with sine and cosine. So remember, complementary means that it adds up to be 90 degrees. So if I have two angles that together, they make a right angle. So this angle plus this angle make a 90-degree angle. What happens is if I take the sine of one angle, it equals the cosine of the other one. So here's kind of that rule right here. The sine value of an angle will always be equal to the cosine value of the complement of that angle. So remember, that means that the two angles need to add up to 90. So that means sine of 30 is going to be the same as cosine of 60, and that's because 30 plus 60 equals 90. So as long as these two angles add up to be 90 degrees, the sine and cosine will equal each other. So for another example, if sine of 32 is equal to 0.5299, what's cosine of 58? Well, if we look at 32 and 58, 32 plus 58 equals 90. That means they're complementary. So the sine of this is going to equal the cosine of its complement. So cosine of 58 degrees will also equal that same number, 0.5299. So kind of just a nice little trick. Look at another example. Cosine of 78 is equal to 0.2079. What is sine of 12? Well, 78 plus 12 equals 90. So that works. These are complements of each other, so that means the cosine of one equals the sine of the other. So sine of 12 degrees is going to equal the 0.279 as well. So kind of keep an eye out for those complementary angles, because if they do add up to be 90, then their value equals the same. You'll have cosine of one, sine of the other. So let's look at this one. They're saying solve for x, and they give you sine of 43 degrees equals cosine of what? So we just talked about how if the two angles are complementary, then the sine value equals the cosine value. So I just need to know what's the complement to this. So I know 43 plus whatever x is has to equal 90. So that would be our equation. All we have to do is subtract 43 from 90, and we get x is equal to whatever is left over, which would be, what is that, 47? And so then x would equal 47. And then let's try again. So we see we have a cosine equal to a sine. We know cosine will equal sine when their angles are complements of each other. So 51.5 plus whatever x is has to equal 90 again. So 51.5 plus whatever x is has to equal 90. So we're going to just minus the 51.5 from that to see what's left over. So 90 minus 51.5 is 38.9. And so that is going to be what x equals. So pretty straightforward, not too tricky. So whenever you see a cosine equal to a sine, just remember their angles have to be complementary and add to 90. Hey, so now we're going to get into the actual kind of meat of our SOHCAHTOA stuff, our trigonometry stuff. And that is two different types of problems. One is finding missing sides in a triangle, and then the other type of problem is going to be finding missing angles. So today we're just going to look at missing sides. We're not going to do all of it at once because it gets kind of complicated, or it might be confusing to do both at the same time. So for finding missing sides, when you have a right triangle, we can use, instead of Pythagorean theorem, we can use SOHCAHTOA. So to find a missing side in a right triangle, when you only have one side and one angle, you can't do Pythagorean theorem, because in Pythagorean theorem you have to know two of the sides. But this way, as long as you have one side and one angle, you can use our right triangle trigonometry or our SOHCAHTOA stuff. So you will want a calculator. If you guys don't have one at home, remember you can go to the school and check one out. There's also ones online. You can just Google like trigonometry calculator, and you can find a whole bunch on Google as well. But we're going to be using sine, cosine, and tangent in our calculators as well. So we also want to make sure that it is in what we call degree mode. So in your calculator, you'll want to go and click the mode button. It's next to the blue second button. And just check that this degree box is highlighted. So we don't want the radian highlighted, we want degree. So if it's not, just go down over to it and push enter, and that will work. So we want to be in degree mode. So just careful with that. Also, if you're on an online calculator, make sure the mode is in degree mode, not radians. So I'm just going to circle that. We want to make sure we're in degree mode. So steps for finding a missing side. You are first going to figure out, are you going to use sine, cosine, or tangent? And to know which one of these you're using is going to be coming from the sides they give you. If you have O and H, you're going to use sine. If you have A and H, you're going to use cosine. If it's O and A, you're going to use tangent. So that's coming from our SOHCAHTOA. So that will tell you what angle we're going from and what sides we're using. Then once we know which angle and sides we're using, we're going to set up our fraction. So we're going to set up our SOHCAHTOA ratio, where we're either, say like on this example, we're using tangent of this angle, and we're going to set up the sides. So tangent would be O and A. In this case, we're looking for x on the top of the fraction. So if I'm just solving for x, what we'd want to do is get rid of the 4 by timesing by 4. So now I come over to here, we times by 4 on each side. These 4's cancel with each other. And so I would just in my calculator type in 4 times tangent of 13, and that's going to tell me what x is. And whatever my calculator spits out, that's going to be my answer. So if x is in the top of the fraction, you're going to solve it that way. But what happens when x is in the bottom of the fraction? So on this example, we have sine of our angle equals our opposite side over our hypotenuse. But this time we don't know what the hypotenuse is, x. So what you're going to do is you're just going to switch these guys places. So you're just going to do 11 divided by sine of 42, and that will equal x. So just kind of imagine flipping their spots. And so that the x goes out here, and we would just type in 11 divided by sine of 42 in our calculator, and that would give us our answer. So those are kind of your two scenarios. One where x is in the top of the fraction, one where x is in the denominator, the bottom of the fraction. So let's look at some examples. So we're going to solve for the missing side in each of these triangles using either sine, cosine, or tangent. Again, we need to figure out which of these we're using though. So looking at our triangle, they gave us this angle B right here as 48 degrees. So I want to, from this angle they gave me, label my sides as opposite, adjacent, and hypotenuse. The hypotenuse will always be across from that right angle, our big side. So this is going to be our H. And then the opposite side is going to be coming straight out from the angle they gave us. So coming straight from angle B is going to be our opposite side, and the adjacent side is touching it. So we have our three sides labeled. Now we want to look at the numbers they gave us. They gave us 38, which is our hypotenuse. And they want us to find x over here, which is our adjacent side. We don't really care about the opposite side at all right now. There's nothing for us over here. So they gave us A and H. So now I need to think which of these uses A and H. Well, if we look at our SOHCAHTOA, sine is opposite and hypotenuse. Cosine is A and H. We want to use this one. So I know that cosine of my angle, theta, remember we use this little fancy theta for the angle, equals the adjacent side divided by the hypotenuse side. So that's how you're going to figure out which formula to use. So we're going to use the cosine formula. Now I just plug in everything. Our angle is 48. That's going to go where the theta is. So I'm going to get cosine of 48 equals my adjacent side, which is x, over my hypotenuse, which is 38. So here's our formula. Zoom in a little bit. X is in the top. I want to solve for x. So right now it's being divided by 38. So the way to get rid of that would be to times by 38. So those cancel and x comes back and we get 38 times cosine of 48. This is where you just throw it into your calculator and it's going to give you the answer. So I'm going to just type in cosine. Oh, let's do the 38 first. 38 times cosine of 48. And we're in degree mode, which is good. And then this would be your answer. And they will tell you on Math Excel what to round to for your homework. So let's just say the 10th place for today. So 25.4. So we would say that would be our answer, 25.4. Okay, let's go over to this one. So we have this triangle here. Ignore my 38 right there, but here's our angle they gave us again, this 51. Remember, we never use the right angle. So we're going from this 51 degree angle. We want to label our sides first. So from this side, the opposite side would be down here. The adjacent side is touching it, so that's this side. And then hypotenuse is the long side. So from this one, once you have it labeled, we need to figure out, am I using sine, cosine, or tangent? And that we need the sides they gave us. So they want us to find y, they gave us h. So we are using O and H in this triangle. We don't have any information for the adjacent side, so the A doesn't help us at all. So which of our trig functions, sine, cosine, or tangent, uses opposite and hypotenuse? And that would be sine. So we know sine of the angle equals the opposite side over the hypotenuse side. So setting our info up, we're just going to plug in the info they gave us. Our angle is 51. So I'm going to do sine of 51 degrees equals my opposite side, which is y here, over my hypotenuse, which is 83. And we are trying to solve for y. So just like the last problem, this is being divided by 83, so to get rid of that, we want to times by 83 on each side. Those cancel, and y comes out alone like we want it to. And then this is what we're just going to throw in our calculator. So we're going to do 83 times sine of 51 degrees, and we get back 64.5. We'll just do one decimal again.